or the last section in chapter 10 is section 1.10, classification of matter. Okay, first let's talk about what matter is. Okay. Matter is anything that has a mass and takes up space. Matter exists in 3 states: solid, liquid, and gas. Okay, so a solid is rigid, it has a fixed volume and shape. A liquid has a definite volume but no specific shape. And gas has neither. It has no fixed volume or shape. Gases take on the shape of the container that they're in. Okay. So some examples of solids would be something like salt, sugar, gold ring. Those are just a few examples. A liquid would be something like water, isopropanol, and that's rubbing alcohol. Okay, and a gas, like the air, carbon dioxide, or helium. And this is just stuff that you guys are familiar with. That's why I'm using them as these examples. Okay, so most matter that's around us is one thing or another. It's either a mixture or a pure substance. Matter around us is either a mixture or a pure substance. So a mixture is matter that has a variable composition. So examples of mixtures are things like wood, gasoline, air. So air is a mixture because it consists of approximately 78% nitrogen, approximately 21% argon, and a small amount, so less than 1% carbon dioxide. Okay. So mixtures can be classified into two different categories. So there's two categories for mixtures. First category is homogeneous. Second category is heterogeneous. Okay, so in a homogeneous mixture is visibly indistinguishable. So you can't tell that there are multiple things in that mixture. So that would be something like Kool-Aid, because once you add the powder and mix it in water, you can't tell the difference between the powder and the water. So all homogeneous mixtures are solutions. So a solution is a homogeneous mixture of two or more substances. A heterogeneous mixture is visibly distinguishable. So you can see the different components. So that would be something like a glass of water with ice cubes, or a glass of water with sand. I'm just going to write the word because I can't draw it. So you would be able to tell that there was ice cubes in the water or sand in the water. So you can visibly distinguish the two components of the mixture. Okay. So another type of substance is a pure substance. So this chapter, or this section, is a lot of definitions. So a pure substance has constant composition. So the composition never changes. Something like pure water would be a pure substance, where pure water is composed solely of water molecules. Okay. So that leads us to our next point, where we're going to talk about the difference between physical and chemical changes. So if you take water and you boil it, boiling water, freezing water, melting ice, these are all physical changes. So a physical change changes the form, i.e. the state of the substance, and it does not change its chemical composition. Okay, so those are some examples of physical changes. So going from liquid to a gas would be boiling, because you would produce water vapor. Going from a liquid to a solid is a physical change, and going from a solid to a liquid is a physical change. And there's also something called sublimation, where you go directly from a solid to a gas. So this is called sublimation, and that is also a physical change. So this would be boiling, freezing, and melting. So any of these four changes is a physical change. So boiling, freezing, melting, or subliming something is a physical change. So a chemical change is when a given substance, so this is the definition, a given substance becomes a new, so that's important, a new substance or substances, so it can be more than one thing, with different properties and different composition. Okay, so a chemical change would be something like fermentation, so if you take sugar and ferment it to make alcohol, this is a chemical change. So these are all chemical changes examples. Another example would be oxidation. So that's like if you took a nail and you set it outside for a really long time and the nail rusted. So that's oxidation. And combustion is also a chemical change. So that's burning something. So if you had some logs in your fireplace and you burned them, then eventually you get ash. But this is combustion. So this is also a chemical change. So all physical, let's star this, all physical changes are state changes. So all physical changes are state changes, so that's what these examples here were, and all chemical changes are also physical changes. So you see a difference between what you start with and what you end with. But the important thing to remember is that chemical changes also involve a change in the chemical composition of the substance. So the last thing that we're going to talk about for this section is the definition of a compound and the definition of an element. So a compound is a substance with constant composition, but it can be broken down into elements by chemical processes. Okay, so an example of a compound would be something like sodium plus chlorine combining to form sodium chloride. And an element, and these are what are on the periodic table. These are substances that cannot be decomposed into simpler substances. So, for example, water is a compound and it can be broken down through electrolysis to the free elements, hydrogen, that's hydrogen, and oxygen. So these are your elements in this example, and they cannot be broken down any further. But a compound can be broken down into the respective elements through chemical processes. So that's it for chapter 1. So now in the next video we will start talking about chapter 2 for your exam.